Hi there. Welcome to EE-Craft. In the past few videos, we've elaborated on designing an internet clock and explored using ESP32 based boards to connect to NTP servers for time information. Additionally, we've discussed two different display devices for showing time and date information. In this video, we will be adding a new feature to the internet clock. How about incorporating a chime that plays every hour? Let's explore how we can add this capability to the clock. There are different methods to achieve this, but I'll demonstrate a nostalgic approach by using a popular device from the past. It is an old melody generator IC UM66T. The UM66T is a CMOS LSI designed for music applications and has an on-chip read-only memory containing a musical tune. The device has very low power consumption, around 180 milliwatts, as it is fabricated using the CMOS process. The IC includes a built-in oscillation circuit, so a compact melody module can be constructed with only a few additional components. The UM66 IC has three major function blocks inside it as shown. When an input trigger activates the power to the IC, the tone generator unit, consisting of an oscillator, a rhythm and tempo generator, and a ROM, activates an external speaker unit to play the tune pre-programmed in the ROM. The oscillator frequency is used as a timing mechanism for the tone and beat generator. The output stage of the UM66 may not be able to provide enough current for a buzzer, as the typical current its output can supply or sync is only 1.5 milliamperes. For better sound quality, a speaker and an amplifier are necessary. If you want to dig into more information about how this IC works, you might find the datasheet useful. It talks about the detailed functional and electrical specifications of the IC. This datasheet shown here is found from the internet, which preserves the specifications of the IC. If you're interested to learn about the detailed electrical specifications, or how the tone generator module, or say the beat generator module or the tempo generator module works, refer to the respective sections. The datasheet also shows various application circuit diagrams of the UM66 series of ICs. It also provides a comprehensive list of the UM66 ICs, the identification markings on the ICs, and which tone it is programmed with. In this video, I am using the last one mentioned in the list, which plays the tune of the song, It's a Small World. The IC I am using can only be operated in one-shot mode, meaning we need to reset the power to play the tune next time. This IC might not be in production anymore, or even if it is, I am not aware of it. I could not find if the original manufacturer of the IC UMC Corporation still exists, but you might still be lucky to buy it from someone selling a similar variant online, or might find it as the old musical doorbells or toys and musical clocks, which are scrapped. I salvaged the IC from an old musical analog wall clock that was beyond repair. I used two transistors, along with the UM66T, and a 32-ohm speaker to build a circuit on a breakout board as shown. The PNP transistor is a BC557BJT, which is driven by the GPIO17 of the TT-Go T-Display board. When the BC557 transistor turns on, the UM66T IC receives power and starts playing the music on the speaker. The NPN transistor is a 2N2222A that acts as an amplifier to drive the speaker. In the Arduino sketch for the internet clock, we need to configure GPIO17 as an output pin. When the hour in the time info turns to 0, we need to set this pin to low to play the music. The circuit is constructed on a general-purpose breakout board as shown. Before connecting to the ESP32 board, The melody circuit is checked separately. After confirming the proper operation of the UM66 circuit, the TTGO T-Display board was integrated with it. Once the updated sketch was uploaded, I patiently waited for the clock to reach the next hour. The modification in the sketch is straightforward. The GPIO17 is defined as chime on. This pin is configured as an output in the setup function. Additionally, a basic if statement is included in the print local time function to set the chime on pin to low when the current minute variable reaches 0. The rest of the sketch remains as it was elaborated in the last video posted. We could also create this melody without relying on a hardware circuit. To accomplish this, we will need a fast digital to analog converter capable of operating in the audio frequency range. The remainder of the work involves developing the sketch. If you have experience generating audio using the internal DAC of the ESP32, please share your insights in the comments section. That's all I had for today. Thank you for watching. Please subscribe to EE Craft.